Okay, and then next one is the feature engineering. It is also called as data pre-processing, data transformation. Like they use different terms. All these terms refers the same thing. Okay, and as part of this, we will take a look at how to handle the missing values in the variables and how to convert the categorical variable into numerical. Since most algorithms need numerical features. Okay, for example, linear regression needs all the columns, including the dependent, independent variables, should be numerical. Okay, in case of categorical variables or mixed with the numerical variables, if you find it as part of your independent variables, then you need to convert the categorical into numerical variable. So, and also we need to fix in case of you find any the distribution, data distribution is normal, you need to convert it to normal. Okay, because the linear models assume the variables should have Gaussian transformation, they normally distributed. Okay, in the case of linear regression model, right, it assumes the target variable should be normally distributed. Okay, and also so the next one is finding outliers are present in the data, right? So how do we find out the outliers and how we address them? Okay, so in case of outliers, can we truncate the outliers above certain threshold, or do we need to transform the data using some technique like log transformation? Okay, so those are the techniques that we use, and in some cases we use something called capping. And so the next one is scale the features. Feature scaling. So this is required to give equal importance to all the features, okay, and not more to the one whose value is larger, right? So unless you do the feature scaling, the machine learning model can misinterpret those features have more value, so that for that it will give more weightage. Okay, so to overcome those kind of bias, we need to do feature scaling. So net as part of the feature engineering, we do this kind of task. In addition to that, what we do is supposing that the data is not available in only one sources, so it is available in multiple tables, more than one table. You need to extract the data, and then you need to combine the data, and sometimes you need to extract the data from other systems, and you need to combine the multiple files into a single file. Okay, and you apply some kind of business logic and create new features based on the existing columns, derived features. And these are the tasks that we do it as part of feature engineering. In simple term, any data related issues, we will address it as part of the feature engineering. In addition to data related problem, for example, if you wanted to create new feature based on the existing columns, that is also, we do it as part of the feature engineering. Okay, now let us take a look at, as part of feature engineering, what other tasks that we do it. We do encoding, data encoding. So now let us take a look at what is encoding. So why encoding is required, different types of encoding, and how do we implement different types of encoding in Python. And finally, will summarize, right, what each type of, when we need to use which type of encoding. Okay, so first of all, what is encoding? Encoding is a technique of transforming or converting your categorical variables into numerical values. This I already discussed, right? But I did not show you how to implement them in Python. Okay, there are different packages that are available in Python, or classes that are available in Python to transform the categorical values, numerical values. Okay, so that it would be easily fitted to a machine learning model if you convert the categorical numerical variables. Okay. So before we getting into the details, let us understand about the different types of the categorical variables. We know the types of categorical variables as part of descriptive statistics. I've discussed about it. There are two types of categorical. One is nominal and other one is ordinal. The nominal variables are variables that have no inherent order. In the case of ordinal variables, it has, inherently, it has some kind of order in it. Okay. So we know very well the distinction between these two variables. So nominal variable is something, for example, gender. You have a column called a gender. In the case of gender, you have two categories. One is male, other one is female. And you have another column like mutual fund risk. In that column, you have something like there are some mutual fund are categorized as high risk. There are some mutual funds that are categorized as medium risk. There are some mutual funds that are categorized low risk, high, medium, low. So in that case, though it is a categorical variable, the mutual fund risk column, it's a categorical variable, but it has some order in it. The medium risk mutual funds, right, so compared to the high risk, the low risk mutual funds are, so people can invest it there, right? So you can go and invest more on the low risk, but again depends, right? If the low risk but return is less, some cases the high risk high return will be there. Okay, it depends on the, but with the help of this categorical variable, you can understand which all mutual funds are high risk, which all mutual funds are medium risk, based on which you take a call. But the medium risk mutual funds are, the risk is lesser than the high risk mutual funds. There is an order here, right? Something is superior, something is inferior. So those kind of variables are ordinal, and gender kind of variables are nominal. Supposing you have some column, some other column like defect type. So yes or no, yes. So, or defect type also you have, let's say defect, defects. You have something called defect, right? So defective is defective. You have a column called D is defective. In that, yes or no will be there. Let's say you are part of a manufacturing unit. You are, after producing the product, you are doing the inspection. During the inspection, your quality control manager, okay, you are doing the inspection, but there are some products you found some defects. There are some products you did not find defects. So in that case, you have a column in your Excel sheet. You say these are the products. Yes, yes means defective products. These are the products or no. So in this case also, right, we just classifying which all products are non-defective, which all products are defective. Okay, it doesn't mean the defective products are superior than non-defective products. Okay, obviously, right? So there is kind of the defective, non-defective products are, but here there is no rank, right? There is no rank. That is what I'm trying to say. But still, it is a nominal type of variable. Supposing the defect severity, you have a column called defect severity, high, medium, low. So in this case, there is a rank, inferiority, superiority. Higher the defects, higher the defects, yes, it is a very sensitive one, and lower the defects, the risk is less, right? So there is an inferior, superiority. There is a ranking here. So these kind of variables are falling under ordinal type of category. Okay, this is fine. So next, what we will do is, so let us take a look at what is the different types of encoding, label and binary encoding, right? This is one type of encoding. And next one is one hot and dummy encoding, and one hot encoding with many categories, target encoding. Different types of encoding is there. Okay, what we will do is we will take a look at the important encoding techniques, which we use it more frequently. Okay, so what is, we'll start with understanding one hot or dummy encoding. Okay, the categorical data are represented as vectors of zeros and ones. Okay, so create a separate dummy variable for each category and setting the value of the dummy variable to 1 if the observation belong to that category, 0 or otherwise. Okay, 0 otherwise. Okay. So when can we use this one? For example, in the case of gender column is there, male or female, right? So you can, but male, female values are there in the gender column. It is a categorical variable. It's a text data type. You cannot mix the text data type with the numerical variables as part of your independent variables. All your independent variable should be numerical, but I have a mix of numerical as well as the categorical variable. In that case, you need to convert the categorical variable to numerical variable. But the dummy encoding, what it says is, if you have gender column, so what you do is you create two columns like male or female. So whichever customers are male, you flag them one, in that record, and then you flag them 0 in the case of female. Okay, so that is what your dummy encoding. So one hot encoding, okay. And so you basically, we use zeros and ones. So binary and binary coding, okay. So to transform your categorical numerical. So another example is the region. In the case of one hot encoding, for example, given the data looks like this, okay. Customer has given you the data that looks like this, the invoice number. So invoice number 1000. So this invoice we raised in South region. This invoice we raised in North region. So we have a region column, and we have something like quantity, price, and discount. So in this region, South region, in the invoice number 1000, how many quantities we sold, what is the price, and how much discount we have given. Okay, so here the region is a categorical variable. Okay, so what we are trying to do here is, we perform one hot encoding on the region column. Okay, so in this case, we have 4 categories are there: south, north, east. For 4 classes or 4 categories are there in the region column. So what we are doing is, for each region, we are creating separate column. And then, for example, this record belongs to South region. So what you do is, invoice number 1000. Since we raise the invoice in the South region, we flag this one. 1 means true, 0 means false. The invoice number 1000, we did not raise it in North. See, we raised it in only in South region, and we put flag, and rest of the region we put 0. Okay, so by doing so, if you look at each and every column, it's a numeric variable. We don't see any text in it, right? The quantity, price, discount. So in this case, quantity, price, discount, only these 3 columns are quantitative in nature. We cannot use the invoice number to train your model, okay? And we can use a region. Okay, region column is a categorical variable. So if you use these 4 independent variable, 3 of them are quantitative, and 1 is the categorical variable. So hence you need to convert this a numerical variable for that. But here we have, it's a nominal type of variable. Region is a nominal type of variable. It is not an ordinal type of variable. It is not that south is superior than north. There is no superiority, inferiority comes in picture here. It is a nominal type of variable. In the case of nominal type of variable, categorical variable, we perform or not encoding. Is it clear or not? Okay. Fine. How about Karthik is okay? How about others? Aruna and Jeevan. Aruna and Jeevan. Others are clear? Okay. Fine, right? Okay. Now we will see how we can implement them in Python. How we can implement them in Python. Because in Python, you have a host of packages are available to perform one-hot encoding. For example, I just go to the, okay, here I just go here, and what I will do is, let me just open a new thing here. I have a file called salaries.csv, because in this file I have the mix of both categorical as well as the numerical variable are available in the independent variables. Okay, and here what I do is I just take a look at the df dataset. Df.head will give me the top 5 records. df8. Okay, and this is the one. And now what I do is df dot rank. So here I can see that df dot rank. So look here. So in this file, we have 1, 2, 3, 4, 5, 6, 7 columns are there. Okay. For example, to check that, df dot shape. We have 7 columns, 2, 4, 6, 7 columns are there, and 397 records are there. In the case of rank column, I can see professor, assistant professor, associate professor is there. Okay. So this is a nominal type of variable. It is not that professors are superior than associate professor. Assistant. There is no inferiority, superiority here. Okay. All are employees. Maybe, there will be some kind of rank here. Okay. But this is kind of a nominal type of variable only. Right? Nominal type of variable. And discipline, we have some different types of disciplines are available. Yes, since PhD, the 6 column is available. Right? 6 is also a nominal type of variable. And we can see the thing here. So now with this data set, we will see how we can implement the one hot encoder. Okay. So there are 2 types of classes are available. One is the from category encoders import one hot encoder. This is one of the class that is available here. And I just imported the one hot encoder class. Here what I do is ex equal. What I do is df of rank. Only this column I want to create the one hot encoding. Okay, what I do is some name I just give. So I'm going to create an object for this class encoder, one hot encoder. Calls, we have a parameter called calls, and here I'm going to say rank. And the next step, what I do is I just say see features. I'm going to apply a function fit transform on the x variable. Okay, because x is in this case a rank. Okay, so I'm going to transform the data using by applying the fit transform function. So the next step is I just print the CE features. Sorry, there is a one hot encoder. This is spelling mistake here. One hot encoder, correct. Import name one hot encoders. Cannot remove one hot from category. So this is from okay, one hot encode. So a lot of typo here. Fine, super, right? So we have a the package called category encoders are available. In this package, we have a class called one hot encoder. I have set up a object C one hot, okay, to instantiate this class. And next one is what I do is I apply the fit transform function on this data. So right, so this is the one right, the one hot encoder, right? So this is the object, right? In this object, I have fit transform. So with this, with the help of this object, right, I'm going to apply the function fit transform on the variable x. Now look here. First record, look here, guys. If you cannot understand, I don't know. Even 12th standard students, they were able to understand this one. See, if you are able to understand, you be generic. Say, I understood, right? You're not able to understand, don't be generic. Make it upfront, sir. I did not understand here. So in this case, tell me what this one says, 100. What is this 100? So rank 1, rank 2, rank 3. This column, right, it did the one hot encoding like this, right? So in this categorical variable, we had four classes or categories. In the rank, we have three categories: professor, assistant, associate professor. I know very well about the data. Okay. And what happens here is, for the three categories in the rank column, it creates three different columns. The column name is different. The naming convention is chosen by the package. Okay. And here, rank 1, rank 2, 3. So what does this 100 says? For the first record, it says the rank is 100. So what does it says? So what I will do is, Professor, Karthik Professor, and Gilbert. How about others? So let me just do one thing here. Let me concat PD concat my data frame. I'm going to concat this with my data frame. Okay, and see features. And without file, you need to say axis equal to 1. So we know the concat, we have two options. One is axis equal to 0, another one is, look here, now I made this features as part of my data set. If you look at here, now you should be able to tell. Forget about the rank column, because the rank column is no more helpful. It is not required. When you train your model, you're not supposed to use the rank column. Instead, you need to use rank 1, rank 2, rank 3. Okay, very good, Sumati. Okay, and here in this case, the first record, forget about rank, right? So this record in the rank 1, it mentioned professor. Rank 2, rank 3 is, it flagged it as 0. That means this guy, this guy is professor, is neither an associate or assistant professor. And if you go here with this data itself, we can understand. Look here, this guy is an assistant professor 1, right? With this data, you can see it here. That's why I concatenated that output with this one. Fine, you are able to get it right. So this is how you can do the one hot. You can convert your categorical variable into numerical variable by doing one hot encoding. But here the challenge here is you might be facing this issue. I know what Gilbert will ask. So the thing is, like, this when you try this in your laptop, it will say the package not available, not found. Okay, so in this case, what you need to do is, what you need to type, pip install category underscore encoder is equivalent to 2.0. Okay, so you can specify the specific version or the release of the package also here by using the double equal sign. On the right side of the double equal sign, you can specify this one. So what is this exclamation? So execute this command in the OS operating system. Okay, that is what this one says. Inside this, see, you don't have to go to DOS prompt, you don't have to execute it. So inside the notebook itself, you can tell Python, hey, this is an external command. So what it is, you take this command and execute in the operating system and install. This is the reserved word. Okay, pip is a utility using which you can install new packages. In my case, I've already installed it. Okay, I struggled a bit and then I was able to install it correctly. Okay, so pip install. Here I just commented it. I will share this code to you all. You can also give it a try. Okay, and so that, but in your case, you need to uncomment it. You need to uncomment it and then give it a try. So apart from this, we have other package that is available to perform one-hot encoding. So what that one is, sklearn pre-processing. Sklearn pre-processing is also one of the popular package from sklearn dot pre-processing. So this sklearn comes with the one-hot encoding tool, which is a built-in. Okay, the one-hot encoder class. Okay, import the one-hot encoder class. Encoder spelling correct. Okay, and what I do is, let's call our class one-hot encoder. So in other words, right, we initialize the one-hot encoder object and assign it to a variable called OHE. One-hot encoder. Here I just say sparse equal to false. Okay, and okay, let it be there. That's all. So the next one is print over here, OHE, and we will see what happens. Is this working fine? Yes, one-hot encoder, right? So sparse equal to false, fine. And so we can see that in the output, it is an object of the class OHE, right? It is an object of the class OHE. Okay, that's what we can see it. So now I'm going to apply the method fit. The next step is OHE dot fit underscore transform, and here I said rank column, but you need to make sure that you are using an extra square bracket. Okay, this is the one you need to make sure that. Okay, so now we are fitting and transforming our data using fit transform method. Okay, so in the output, we can see that we have successfully converted our variable rank into a one-hearted encode variable. Okay, now I'm going to save this result. Okay, let's say I'm going to call a variable called feature array. Here it is slightly different. Okay, here 001, whereas here 100. Okay, so we need to understand. Okay, so here 001, the first record belongs to, so the third one belongs to professor. Okay, and the middle one is assistant professor. Feature array. Here I'm going to use the OHC dot fit. I just copy paste this one simply. Good. So now we are able to do this one. And the next step is, okay. So now you might be in a dilemma. So what this 0, 0 and what this 1 is, right? So in order to understand this better, so in this thing, right, we have something called, if you want to look at the categories, right? So you can use OHE dot categories. Look here. So the 0 is related to assistant professor. This is related to, this is associate professor. This is assistant professor. The last one is the professor. So because you will get, you might get confused with this output and this one. But here, the one is for professor, it assign the one here, whereas here, you assign the thing here, right? The here you can see the categories using which you can, but here there is no feature. I think there is nothing is available. Probably I'll check and tell you, okay, how to check the categories for this one. Okay, we can, I'll check and come back. But in this case, there is something called categories underscore. This is the one is available. So if you execute this one, you will get to know, what each column is all about. This belongs to associate professor. This belongs to assistant professor, and so on. So using one hot encoder that is available, that class which is available as per scale-on.processing, also you can do this one. And we have another option called pd.get underscore dummies, using which also you can do the rank. Okay. And now what we will do is, same way you can concatenate this one with your data frame. For example, if you want to concatenate this one with your data frame, you can do it that one also. In this case, OHE underscore categories, right? Okay, what I can do is we can create a data frame. Okay, for example, I have something called features is equal to pd dot data frame. The same way, let's say in this case, a feature array, comma the df. Okay, and here feature array, okay, columns, or I can specify something like this one, sorry. Columns is equivalent to OHE dot categories. You can say that way also. Let's see what happens here. Yeah, say the feature. Okay, so here, okay, here, look here. In this thing, it is not, each column is not defined with the column header. If you want to define the column header, you can do it this way. Okay, So the categories, you specify the columns, you can use the data frame, PD data frame, and then the feature array, which has the array values. But to give some column name, right, you can use this way, you can do it this way, okay? And next step is you can concatenate this one with the data frame. For example, I have, listen to my final data frame, right? So I'm going to update my existing data frame with this one, pd dot concat the df comma features. Importantly, axis equal to 1. So axis is 1, what it says is column wise concatenation. If you specify 0, row wise concatenation. If you use 0, it will do the append one after another, okay? But axis 1, so let's say you have 10 columns are there, along with it, this one will get concatenated. So I just type df here and we will take a look here, the rank column, discipline, look here, the associate, whatever thing that we have given, right? So it got this associate professor, and it shows very clearly in the professor, it shows 1, okay? So in this case, all these 3 columns are numeric variable. This is not numeric variable. Okay, you can drop this column, or for your reference, if you can retain it. But when you fit a model, when you build the model, you can use these 3 columns instead of this column, okay, right? Fine. And we have gender column, sex, right? Sex is a, the gender column. So what I do is I'm going to use another method called pd get dummies, okay, df dummies, for example, using which also you can do the encoding, get underscore dummies. The get dummies is available as part of pandas itself. df columns is equivalent to, I say, sex. It's not SCD, it is sex. Look here, using get dummies. See, apart from one hot encoder class that is available as part of sklearn.preprocessing, and also you have one hot encoder that is available in another package called category and encoders, right? So you can, the one hot encoder is available in these 2 things. Whichever thing you need it, you can use it. But sklearn processing, pre-processing one hot encoder is widely used. Instead of that, you can use get dummies itself. So for this, you don't have to have the headache of import the class, and you don't have to create an object for that class, and you don't have to fit transform. You don't have to do so many steps. Simply you specify get dummies and you can do it. But the challenge with this one is for training and test data set. If you want to do one hot encoding, the skill and dot processing is a good one, because you need to do the get dummies for training separately and testing you need to do it separately. But in that case, right, the sklearn dot processing is much better, okay? So most of them they use for one hot encoding, they use sklearn dot pre-processing package. As part of that, the one hot encoder class is available. That is the one is used, okay? And next step is, okay, now the sex underscore female, I just want to rename this one as gender. Instead of sex, I want to rename it as gender. So what I do is I have something called prefix option, prefix. Here you can specify the to be column, what name you want to give it. Okay, and prefix is equivalent to the prefix separator. You have something with separator equivalent to dot, okay, gender dot female, gender dot male, it will give you, okay, column equal to sex df dummies. Look here, instead of sex underscore female, and you can define the separator, either you can use dot or underscore, you can specify it. So using get dummies also we can do it. The encoding, okay, encoding you can see in the case of yeah, so in both the cases, right, whether it's a one hot encoding or, so we are doing the binary encoding, because these are all nominal type of categorical variable. And okay, the next thing is, okay, can I do the same for the rank? Look here, even for the rank. So this is, these columns we concatenated from the one not encoder, but using get underscore dummies, also you can do the one not encoding. But most of them, they prefer sklearn or pre-processing, that one not encoder class only for doing the one not encodings, right? So, but PD, this is also fine. Get dummies, okay, but the problem is you need to do it separately for training and test, right? So, whereas with one not encoder, you can do it together, okay? That is, and other thing is, okay, do I need to specify the columns one separately, one at a time? So can I can't I specify more than one column at a time? Yes, that is also possible with get dummies. For example, you have something called rank, and you can see the sex here. Look here, rank dot female, rank dot male, and but again, so because I've given this one, right, it is giving this one, and instead you can remove this one, and then you just fit it, and then later on you can change the name. So look here, sex male, sex female, and rank associate professor, right? All the you can do professor one now, and associate professor 001. So the get dummies and one hot encoder class that is available as part of sklearn.preprocessing, right? It does the same way, right? So 001. But whereas in the case of categorical encoders, it is opposite in the reverse way. The first it does the puts the professor one, and then assistant professor zero, and then associate professor zero. The order was different in that case, right? The category encoders, one not encoders, and the PD get dummies, it does the same way. Okay. Fine. So in this one, in this demo, you have seen how to do one not encoding for a single category, multiple category, like a rank and sex in one game. How can I do that? You have seen it. And then we have seen it, right? So, okay, next one is ordinal encoder. What if my column has order in it? This is an interview questions. See, all these are very important topic. Okay, so what I'm going to do is in that case I am pretty comfortable with the category encoders when it comes to the ordinal type kind of thing. Okay, encoders, import ordinal press tab. It is not coming. Ordinal encoder. Okay, here you need to use something called mapping. Here I'm going to use a dictionary. So in that dictionary, key value pair, for example, column rank. I just specify the column is rank column. For the rank column, you need to do some kind of mapping key value pair. Mapping is the text value, hence assistant professor. Whatever the number that you want, you can specify the order. Okay. So here we simply specify 1, 2, 3. Associate professor. And then here I just copy paste this ordinal encoder. Dot fit df dot transform df. Okay, invalid syntax. Here I've used true equal sign and mapping. Okay, here mapping. Okay, call key value pair. Okay, and I've okay. Here I should use. I've used this one. Oh, I just used it for this one, and this is for. It is not taking for that one. 1 second. What is any problem? Rank column should close. Okay, rank column should close, right? So Sumati, very good. Sumati became expert. Very good. Oh, this is the one. Excellent, Sumati. Very good. So this is the one, right? Good. So now if you look at it here in the rank column, look here, everything got disappeared, right? So for the first one, we know very well, first record was professor. Look here, in this case, the rank professor is 1. The first record is related to professor. Hence the professor value we have given here, hence, it replaces the professor by 3. And 1 is assistant professor and 2 is the associate professor, because it displays only the top records. Okay, and that is what we can see there. Very good, right? It is doing the ordinal, for the ordinal encoder, it is doing the best job, a good job in terms of mapping or encoding the 1 2 3. Okay, the ordinal encoder is doing good job. So with this we can do it. Okay, so now we understood, how to perform one-hot encoding, how to perform ordinal encoders. In the case of ordinal variable, not nominal variable. In the case of ordinal variable, you need to use ordinal encoder. In the case of nominal type of variable like gender, right? In those kind of situation, you can use the one-hot encoder. Okay, and you can sit, for example, in the case of gender, you can, right? So you can use gender and all, right? Simply you can specify 0 or 1. Fine. Okay, so you can use it. Okay, here now the question is, why can't I use 1 2 3 even for the rank column? Okay, why can't I? So let's assume that in this case, the rank is a categorical variable. Rank is a categorical variable. With that assumption, we did the one-hot encoding. Okay, so instead of doing one-hot encoding, can't I use 1 2 3? If you use 1 2 3, what it does is it will think this professor is superior than this person, that person is superior that. There is some kind of inferiority. I know the model will think the professor is superior than the associate professor. The associate professor is superior than assistant professor. Something like the model will think, it will start interpret this way. In the case of nominal, that is the reason why you need to first understand whether the given categorical variable is a nominal or ordinal. If it is an ordinal variable, you can use ordinal encoder. If it is a nominal type of variable, one-hot encoder. It is as simple as that. Now the question is, we have explored 3 different packages like sklearn.preprocessing, categorical category encoders. So which one should I use it? So you can check the performance, okay, whichever the package that returns the value or does the encoding in a pretty fast way, that is the one use it. In general, we use sklearn.preprocessing. That is the one is very good one. And I would suggest you and explore how we can do ordinal encoding with the sklearn.preprocessing. That I will leave it to you. Okay, you just explore it, how we can do it. Fine, we have learned how to do dummy coding in Python using pandas, get dummies and method and other classes also. And importantly, we have worked with the categorical data with 2 levels and categorical data with 3 levels, right? So we have seen it. And also we have seen how to perform ordinal, in the case of ordinal encoding, how do we perform the encoding? In the case of nominal type of, how we can perform the encoding, we have seen it using one-hot encoder and all. Okay, now the situation is, we have something else called dummy code trapping. Okay, we have something called dummy variable trapping. So what is dummy variable trapping? The dummy variable trap is a scenario, right, in which the independent variables become multicollinear after you include the dummy variables. For example, in the case of a region, we have 4 categories: north, south, east, west. Just because we have 4 categories that are that were available as part of region, we created 4 columns. This is not the right way of doing it. So this can lead to dummy variable trap. Okay, so in that kind of situations, what we have to do is we need to do k minus 1. We need to create k minus 1 columns for the categories. Let's say you have k categories in your region column. So for that, you need to create only the k minus 1 columns. So 4 categories are there. 4 minus 1, 3 categories only you need to create the one-hot encoding. Okay, probably you can drop any one of the variable here. So this is the way, but now the question is, what is wrong if I create, let's say I have a k categories are there. For k categories, if I create k columns, what is going to happen? If you create like this, it can lead to dummy trap, variable trapping, which means there will be multi-collinearity issues. There is a collinearity between the independent variable itself. That is one of the assumptions as part of linear regression. You remember it. There should not be any correlation exists between the independent variables. That means multi-collinearity. You will land up with multi-collinearity issues. This is called your dummy variable trapping. If you do it dummy encoding like this. So what is the way out now? So what is the way out? For example, okay, here in this case, you have something called drop. Okay, drop equal to first. For example, here rank, I've given rank, right? Here in the get dummies, we have an option called drop first equal to true. There is a parameter called drop underscore first equal to true. Okay, if I do it, drop. And if you look at the rank here, look at here, forget about these 3 columns. This one we did it using one-hot encoder class. Okay, this is using get dummies. Now what happened? Instead of creating 3 columns, it created only 2 columns: assistant professor, rank professor. It dropped the first column, the associate professor. Okay, so by doing this way, we can make sure that our encoding will not land or leads to dummy variable trapping. So in the interview, they'll ask you, what is dummy variable trapping? In case of any multi-collinearity. So look here, if a qualitative variable has k categories, what is a qualitative variable? Region. Okay, if that has k categories, in this case 4 categories, introduce only 4 minus 1 dummy variables. So 4 minus 1 is 3, right? So 1, 2, 3 are not supposed to have 4. If you have 4, it can lead to multi-collinearity. You need to remember this simple thing, okay? Failing to follow the above rule, it can lead to dummy variable trap. It is the perfect situation of perfect collinearity. So here itself I mentioned, right? So which, okay, now the question is, in the get dummies, we have an option to drop first, right? We can do it. Is there any other option that is available in one-hot encoder itself? Yes, in the case of pre-processing, so sparse equal to, and here you can specify drop is equal to, there is an option called drop that is available as part of your one-hot encoder class that is available as part of pre-processing. So, and if you do it this way, look here, and I just do it this way. And this is the previous one. I'm not going to disturb this. And now what I do is I just do the same thing here. This is for our reference. Okay. Look here, in this case, the first column got dropped. Okay, and you can see the OHE dot categories dot categories underscore. Oh, here, okay, okay, that is available with that one. One second. Here, y dot OHE dot categories underscore, right? Yeah, so but still it shows the 3 columns here. Okay, it shows 3 columns, but end of the day you will have only 3. But in this case, it will be a little bit challenging if you wanted to concatenate these 2 columns into your data frame. Okay, that one is little bit different, but with the first parameter, sorry, drop parameter, right? You can specify first column, you can drop it, okay, in the one hot encoder. And similarly here in the case of get dummies, drop first option is available. As per get dummies, you can use that one also. So there is no harm in using get dummies in place of one hot encoder, but that is the one is used, that is the standard, right? Most of them they use it because when you use the train and test data set, that is the best thing. Okay, the sklearn dot pre-processing. Fine. Okay. The next one is what else we have? Okay, ordinal encoding also we have seen, right? So the each category assigned a numerical variable. In this case, label. Okay, how we can implement them in Python. So I have mentioned the script also here, which the package name, all the options also I mentioned. Target encoding, I'm not going to talk now because at this moment this is sufficient. Even you have a lot of other techniques or feature hashing everything, so probably I will cover it later in the interest of time, but these are the important thing. Okay, the one hot encoding, and then the scale and pre-processing, right? And get dummies, if you know that, that is more than sufficient at this moment. We'll discuss rest of them later. Okay, in the case of target encoding, we encode the category values of the feature by using the target value. Using the target value, you'll be doing it. That we will discuss it later. Okay. And to summarize, you understood what is one order. It is the most commonly used method for nominal variables. The ordinal encoding is used for the ordinal type of variable. And we have something called frequency count encoders, feature hashing, and target one, which we will discuss it if time permits in the later point in time. Probably in the later session, I will discuss about this. At this moment, these are the 3 important things you should be knowing. Okay. And dummy trapping also we discussed it. Right?